Hello guys, how are you? I hope that you will be very fine and I am also very fine. Today I am going to discuss a very important topic which is called as Coulomb's law of electrostatics. This law was first given by Coulomb and hence this law is called Coulomb's law of electrostatics. This law is very important for NEET examination as well as IIT JEE examination. This law is also very important for 12th examination. Some numericals are always asked in NEET examination as well as IIT JEE examination. Some theoretical questions and numericals are always asked in 12th examination also. Therefore, this topic is very important for 12th examination, NEET examination or IIT JEE examination. First of all, I am going to explain Coulomb's law of electrostatics. For the explanation of Coulomb's law of electrostatics, I am going to take two static point charges which are separated by a distance r. If the nature of charges are similar, that is like charges, this means that both are positive or both are negative, then there will be force of repulsion. If both charges are like. If the nature of charges are opposite means one is positive and other is negative, then there will be attractive force in nature. If like charges are separated by distance r, then there will be repulsive force. If unlike charges are separated by a distance, then there will be attractive force. Here both type of forces, repulsive as well as attractive, are possible. Therefore, here I can say that the force of interaction. But in gravitation chapter, the force acting between two point masses is always attractive in nature. It is not repulsive in nature. Therefore, I can never say there the force of interaction. But here the force of attraction or the force of repulsion, both are possible. Therefore, here I can say that the force of interaction. Is it clear? First of all, I am going to explain this according to this law. The force of interaction. What is the meaning of interaction? There will be possible repulsive force or attractive force. The force of interaction between 2 point charges point to a static point charges. To a static point charges, because this law is valid only for a static point charges. It is not valid for moving point charges. A static point charges will be here as the magnitude of these charges increase. As the magnitude of these charges increase, the force of attraction between these point charges also increases in the same ratio. Therefore, I can say that the force of interaction between these 2 point charges is directly proportional to the product of magnitude of charges. Whenever the magnitude of charges will decrease, then the force of interaction will also decrease. This means that the magnitude of charges will increase, the force of interaction also increase in the same ratio. This means that the force of interaction will be directly proportional to the product of magnitude of charges. If one quantity increases, other quantity also increases in the same ratio, then you can say that one quantity is directly proportional to the other quantity. If one quantity increases, the other quantity decreases in the same ratio, then you can say that one quantity is inversely proportional to the other quantity. Similarly, whenever the magnitude of charges will increase, then the force of interaction will also increase. This means that the force of interaction is directly proportional to the magnitude of these point charges. First point is directly proportional to the product of magnitudes of point charges. Magnitudes of point charges. That is F is directly proportional to magnitude of Q1, magnitude of Q2. If you have sufficient time in the examination, then you can write this language also. If you have not sufficient time, then you can directly write this mathematical expression. The second point is please look here at the board. If separation between the charges decreases, what will happen? The force of interaction will increase in the same ratio. Whenever the separation between these point charges increases, then what will happen? The force of interaction between these charges will decrease. If the separation between these point charges will increase, this means that the force of interaction between these point charges will be inversely proportional to the square of separation between them. The second point is inversely proportional to inversely proportional to inversely proportional means whenever one is increased, then other is decreased in the same ratio. This means inversely proportional. Inversely proportional to the square of separation between them. What is the meaning of separation? What is the meaning of separation? Anyone can say? Meaning of separation is the shortest distance. Meaning of separation is the shortest distance between 2 points. You can write separation or shortest distance. Both are correct. Shortest distance means separation. Separation between them or point charges, both are same. Separation between them, that is F inversely proportional to the square of separation between them. Combining both points, we get if separation becomes 0, then what will happen? If separation becomes 0, then force will become infinite. If separation between the charges becomes 0, then the force of interaction will become infinite. Combining both we get. Combining both we get. If separation between the charges will infinite, if separation between the charges will become infinite, then if the separation between charges will become infinite, then force of interaction will become 0. Combining both we get F is directly proportional to Q1 modulus of Q1 modulus of Q2 upon R square. This should be equal if there will be a constant. Constant is K. Q1 modulus of Q1 modulus of Q2 upon R square. This constant is called proportionality constant. Proportionality constant. And its value is K should be equal to 1 upon 4 pi epsilon naught. This will be equal to 9 cross 10 to the power 9. What will be unit of this constant? Unit of this constant can be written as, this is K, R square should be multiplied with force Q1 Q2 will be divided Q1 Q2. What is the unit of Q1 Q2? Coulomb into Coulomb square, or this is Newton, or this is meter square. R square is multiplied with force. The unit of force is Newton. Newton meter square per Coulomb square. So I can write the unit of K is Newton meter square per Coulomb square. Is it clear? What will be force? F is equal to 1 upon 4 pi epsilon naught Q1 Q2 upon R square. This is the final expression. In 12th examination, you should write up to the expression of force. This law has some demerits. First demerit is this law is valid only for point static charges. It is not valid for moving charges. It is only valid for point charges. It is not valid for any arbitrary shape of charges. It is not valid for any arbitrary shape of charges. It is only valid for point charges. In case of arbitrary shape, the measurement of separation between them will be difficult. So Coulomb's law is only valid for point charges which are static, not moving.